All right, yeah, so I'm just going to talk about how philosophers view current empirical research into consciousness and bring up some of the barriers that research program has in terms of ever giving us a complete theory of consciousness. And also mentioning, in particular, a problem with this program, even considered as a modest project that is not supposed to ever give us a full understanding of consciousness. Oh, it's fine. Is that better? Okay, cool. All right, good. Okay, so the first question to start with, as we've already seen, is just to give ourselves a sense of what the target phenomenon is that we're trying to understand. And although, as Brown mentioned, consciousness obviously is something that we're all particularly intimately familiar with, and in some sense, therefore, needs no introduction. It turns out that the word consciousness, as it's used in the English language, is somewhat ambiguous, and as a result, discussion can get somewhat murky if people talking past each other by meaning something different. So it's worth just getting a little bit clear about which thing we have in mind. So the thing that seems particularly mysterious is what philosophers call phenomenal consciousness. So phenomenal consciousness is, so I say this phenomenally conscious if it's something that contributes to what it's like for you subjectively at a given moment of time. So phenomenal consciousness is the strange, mysterious light that switches on when you wake up from a deep sleep. It's the thing that we're all particularly terrified of losing when we die. But really, we can't actually give a definition of what it is. We really just have to know what it is from being subject to it and kind of just pointing to it inside yourself. And actually, it seems to me that really the source of all the problems we have in understanding consciousness comes from the fact that the way we pick it out in the first place is not by some physical definition, but just by a kind of internal pointing. Okay, I'll get back to that. But anyway, it's arguably different from self-consciousness or self-awareness. So our conscious experiences invariably just involve us being aware of things that are external to ourselves, like surfaces and their colors and patterns and so forth. So it seems like we can easily imagine someone having conscious experiences in the absence of any serious conception of themselves or self-awareness. And also, more controversially, phenomenal consciousness is different from what we might call consciously noticing some state that we're in. So, for example, you can imagine feeling some sensation for an extended period of time. And whilst you're feeling that sensation, some of the time your attention may be drawn to other things, like you might be engaged in a conversation or something. And it may still be true that whilst your attention is drawn away, the fact that you're feeling that sensation is making some difference to your conscious life. So in that sense, it's a conscious experience. But it's not conscious in the sense that it's the focus of your conscious attention. You're not consciously noticing it, even though it's a conscious experience. Okay, so one question that philosophers have tried to address is the question of adequately characterizing the current empirical project to understand consciousness. And there's really two main questions that it addresses, as we've actually already been mentioned. The main focus is really on the second question. So one question you might think you'd be interested in as a scientist is just, what exactly is the physical property that is required for consciousness? What exactly do all internal physical states that involve consciousness have in common physically? And as we heard, there has been some attempts to uncover information about that question. For example, at least in humans, it seems like activity in the thalamus is correlated with the difference between sleep states and awake states. But as I'll say in a minute, it's unclear how that kind of information really could ever lead to a full answer to this question. But the main issue that's really addressed by the current research is not that question, but rather the question, what are the neural bases in humans for particular kinds of conscious experiences? So, for example, what has to change inside you for your in order to have one particular type of experience rather than another? And the sort of technical way of explaining this that philosophers use is in terms of the difference between a total basis for a type of experience as opposed to a core basis. So, for example, suppose we're interested in what the neural realizer is for the experience of a particular shade of red. The total basis for that is going to be activity in your brain that alone is sufficient for you to experience that color. And in particular, it will include activity that enables you just to be conscious in the first place rather than asleep. Whereas the core basis is just the particular activity that distinguishes the fact that you're having a red experience rather than some other experience, and won't necessarily include the background conditions required for consciousness per se. So we can illustrate this with binocular rivalry, which we've already actually heard about, so I won't spend too much time trying to explain how it works. So in this particular binocular rivalry experiment, left eye gets an image of a face, the right eye gets an image of a house, and somewhat surprisingly, what happens is that your percept oscillates in between an experience of a house and an experience of a place, and at least in monkeys, it turns out this is not quite true of humans. What happens is that there's a corresponding oscillation in activity between two different areas, the fusiform face area and the parahippocampal place area. So this just illustrates. So we might then conclude that the neural correlate of face experience is contained within, say, the fusiform face area. And I'm just bringing this up to illustrate what the concept of a neural correlate is, because the idea is not that activity in that area alone is going to give you an experience of a face. It's not as if you were to cut out that area of the brain, keep it alive, and stick it in a Petri dish and reproduce the pattern of activity, you're going to have an experience of the face. Rather, the idea is that that's what explains the particular kind of experience you're having now, even though it will require other kinds of background conditions being in place, like the thing being connected up to other areas in its own way. Okay. So that's what the project is. So you can see that, I think, pretty easily that if that's the type of information about consciousness we're going to uncover, really all it's telling us is information about what in human beings is sufficient for particular kinds of experience and the difference, say, between sleep and awake states. And the reason why that's not going to count as a full understanding of consciousness is that it's going to be very hard for us to extrapolate out that kind of understanding to non-human organisms and objects. So if we really know what physical property consciousness is, it seems like we should be able to just read off from any arbitrary creature or robot or whatever it is, whether or not it's having conscious experiences. But the problem is that even if we know conditions that occur in humans when they're conscious, we don't know how much of those conditions is strictly necessary for conscious experiences. So we can imagine a hypothetical case. Suppose we're confronted with some alien life form. It displays a level of intelligence comparable to human beings, has complicated information processing. But it turns out that it has quite different biological hardware from the one that realizes our mental lives. And maybe it uses quite different kinds of computational techniques to achieve the kinds of cognitive tasks that it can do. Maybe, for example, maybe it involves a kind of classical symbol crunching computer, whereas we have a kind of massively distributed neural network doing our computations. And you can imagine it just being extremely puzzling whether or not this creature has consciousness. And the reason is that we just don't know at what level consciousness arises. Is it a kind of biological phenomenon, so that to have it you have to have a reasonable level of biological similarity to us, or is it a higher level phenomenon that only requires a certain kind of abstract functional organization in your nervous system? It seems like we're not going to be in a position to answer those questions just from the kind of research we're doing, and it's unclear whether we'll ever be able to answer them. So I want to focus mainly on a problem people have brought up recently for the more modest project of just finding correlates in humans for experiences. But I thought I should mention this thing, the hard problem, that's already been brought up. The hard problem, as it's sort of canonically understood by philosophers, it's not really about whether we can communicate our experiences. It's about whether having a kind of complete scientific, physical type understanding of what's going on inside our brains will leave us feeling completely satisfied that we understand consciousness. And the thought is that even if you knew, say, all the information you could know about the basis of, say, experiencing a certain color, it seems like there'll be a kind of residual explanatory worry that will be there, which is, why is it that this type of physical activity gives rise to this kind of conscious experience? Maybe why doesn't it give rise to some other kind of conscious experience? Or really, the most important question is, why does it give rise to consciousness at all? It seems like we can imagine any particular kind of physical state in the absence of consciousness. And given that we can conceive of it with consciousness and without consciousness, it might seem like we need something that enables us to understand how it could be that consciousness arises just from a complicated interaction of physical states. So there's much more to be said about that, so we can maybe get back to that in the questions if people are interested. But I want to talk about a different problem. So this has to do with whether we can, in principle, find the NCCs of all of our conscious states. And really the way of thinking about this is you might think the target of the NCC project is to enable us in the future to be able to just read off what the contents of someone's conscious experiences are just from looking at what's happening in their brain. And the question is whether we're ever going to be able to do that. So this problem arises from the following simple fact. In a given experimental situation, in order to find out correlations between neural activity and experiences, we also obviously have to know what experiences are going on with a subject during the experiment. But it's not like we can detect directly what conscious experiences they're having. It's not as if there's a kind of consciousness device that you can just point at them and it'll give you a little readout of what's happening in their subjective lives. So we need some kind of way of inferring their experiences from indirect evidence. Very roughly, the working principle people use in this field is just to ask people what experiences they're having. Or more specifically, there's really two types of questions you can ask. More typically, I don't actually ask them directly what experiences they're having. You ask them some question about the stimulus. And if they can reliably answer the question about the stimulus, then you infer that they must be experiencing the stimulus. And in fact, if it's a monkey that's involved, obviously you can't directly ask them about their experiences. You have to rely on that kind of objective test. You get them to report by training them to press buttons and so forth. But also you can just ask humans about their experiences directly. In effect, what happens is that the fact that we're using that type of methodology leads to a kind of framework hypothesis about what the conditions for consciousness are. Namely that information is only in phenomenal consciousness if it's accessible to high-level cognitive processes, like the ability to verbally report your experiences, but also other processes like thinking, decision-making, and motor planning. sometimes this is put forward as a kind of substantive theory. So Bernard Baars has this thing called the global workspace hypothesis. The global workspace just refers to areas that are involved in these higher-level processes. And sometimes also there's this phrase, working memory. It's also used to just refer to those systems. So you can see that if you have that sort of framework assumption, then the whole project of understanding consciousness and its correlates becomes more tractable, because now it looks like what we can do is study consciousness by studying the neural mechanisms that make different kinds of perceptual information available to these high-level processes. And that's just a kind of scientific question that's quite familiar. All the time in psychology, we know that there's a particular kind of process that we can abstractly describe as going on in the brain, and then we just want to know what the underlying mechanisms are that allow that to occur. So if we replace the question with that one, it looks like things become tractable. But you might wonder whether operating within that framework is really assuming too much. Is it really the case that the neural basis of actually, no, hang on, something I just missed out. So, I was going to mention that not only can we pursue things this way, we actually know an awful lot about what the neural basis of accessibility is. So we know that all these high-level cognitive processes occur in the front of the brain, and we know that there's like these long-range connections between the visual system and frontal areas. So the hypothesis that seems to be in the background then is that information is only in consciousness if it involves, if it is being fed forward from the visual system to the frontal areas. And we also know a lot about the conditions under which that happens. Like if information gets amplified by attention, then it's more likely to be fed through, and so on. But is that really assuming too much? You might worry that if you're just studying accessibility, then you've changed the question. Is it really the case that the neural basis of access is the same as the neural basis of consciousness? And more particularly, you might worry that what we're doing here is just making a sort of substantive assumption about what consciousness is. It looks like we're just assuming that consciousness is accessibility to report and so forth. And, maybe that's correct, but if our project is to uncover, in physical terms, what consciousness is, it's a bit unsatisfactory just to make a strong assumption about that right from the beginning. So you might say, okay, well, why don't we just try and test this assumption? What exactly is the link between consciousness and accessibility? And this is where we get a kind of deep problem in the foundations of this type of research, because if you were trying to design an experiment to test the link between the accessibility of information and consciousness, you're going to have to interpret the experiment. In particular, you're going to have to work out what experiences are occurring there. But to work that out, it seems like we're going to have to assume some principle about what makes information conscious. So we're going to just go around in a big circle. We're going to have to assume just the kind of principle that we were trying to test. So this might lead to a worry that we're going to have some kind of framework assumptions about consciousness in place that can't themselves be tested. So that's a very kind of abstract characterization of the problem. I just want to sort of bring it alive by giving you some examples of where it really makes a difference to what view we take of experiences. So we already saw a demonstration of change blindness. And in a lot of these change blindness cases, there's really sort of more than one plausible view of what exactly it is you're experiencing during the change blindness experiment. So when these change blindness paradigms first came out, people just were immediately inferred that until you notice the feature that's changing, it must be the case that you are not at all consciously experiencing the feature, but there are other explanations. It could be that you are having a a kind of rich experience of all the details in the picture, but there's just certain conditions required for you to notice the change that don't play out. So maybe, for example, your representation of the feature that changes just fades out before the next image gets shown, so that you have no possibility of noticing the change, even though you experience it in both cases. More particularly, it seems like there's two general pictures of experience, what we might call a rich view and a sparse view. And the rich view really corresponds more to common sense. We think that at any given time we're having a rich experience of lots of features in the world, and maybe only some of them are like in the central focus of our attention, but nonetheless there's lots of stuff outside that, particularly stuff that's not necessarily immediately accessible. But there is this contrasting view, which is more like the framework assumption people are using in consciousness research, which is that really all you're ever experiencing is what's in the central focus of your attention and it's immediately available. And we might try and explain away this illusion that we're having a rich experience as being what Noe and O'Regan refer to as a refrigerator light illusion. So it can seem like the refrigerator light's always on, even though it just switches on when you look in there. And similarly, you might think you're having a rich experience because whenever you try to examine some feature of some aspect of the world that's outside of your immediate focus, obviously you then focus attention on it and you can experience it. So you can have this illusion that you were experiencing it all along, even though maybe you weren't until you actually focused attention on it. I think probably, yeah, we're not doing very well for time, so I'm going to skip a little bit over. Yeah, I just wanted to mention this particular experiment, which is a variation on the kind of change blindness thing you saw earlier. And it's interesting because it's pretty compelling here that there's at least a good case that you are experiencing all these features, even though you may not detect changes. So what happens in this experiment is that you're showing this array of rectangles. I should have the pointy thing. You're showing this array of rectangles. And there's sort of three different versions of the experiment. In the first one, you're showing the array, then there's a blank screen, and then you're showing an array where at most one of the rectangles will have changed orientation. So in this case, and also there's going to be a pointer next to the rectangle. And the question you're asked is, did this rectangle change orientation? And people are surprisingly bad at this task. They'll only get it right about 50% of the time, I think. So that's a kind of change blindness case where you might then infer that they weren't really experiencing all the orientations of the rectangles when they're flashed to the first image. The second one, the pointer actually comes up on the first image and tells you which one is going to change. And then obviously when that happens, your attention gets focused on that one, and you're extremely reliable at saying whether or not the one that's been pointed to has changed. So the clever thing is this third case where the arrow pointer comes up in between the two images. And in this case, you're extremely reliable, almost as reliable as in the second case, at saying whether or not the rectangle that was in this location has changed. So that seems to be evidence that there was, after all, at least information in your visual system about the orientations of all the different rectangles when you had the first experience, contrary to how we might interpret things just based on this this first version. So it seems like then there's a possibility of interpreting change blindness in such a way that you really are having a kind of rich experience with more in it than is immediately accessible. And there may be alternative explanations for why you fail to notice the changes, which maybe I just won't get into right now. I'll come back to that in a second. So yeah, really the general point here is that although you, in that Landman experiment, you might conclude that you did experience all the orientations of all 8 squares. Really, there's there's still two possible interpretations. Someone might say, yeah, the information about all of these 8 squares was in your visual system, but since you weren't able to actually access, like in a direct way, what the orientations of all 8 were at once, that's evidence that really you only were kind of subliminally perceiving the orientations. You didn't actually consciously have an experience of all the details in the picture when it was flashed up. And we know that there are plenty of cases where you can just subliminally perceive something without consciously experiencing. That's a well-established fact, so there's nothing weird necessarily about that hypothesis. And the problem is that now we're in a kind of situation where it's unclear whether we can ever agree what actually enters into the content of someone's consciousness in one of these particular cases. If we can suppose that 2 people know everything about what's happening in, say, one of these change blindness cases. They agree about all the representations that are there and how deeply they're processed through the visual system and so forth. But they just disagree about how much accessibility to information is needed for consciousness, and therefore disagree about what's happening in the experiment. And there's a kind of analog of that disagreement that you can put in the neural level. So everyone can agree that if there's only weak activation in early visual areas corresponding to some feature of a picture that you're shown, then you didn't experience it. And everyone agrees that if there are these kind of loops that go forward into the frontal areas connecting the visual system with higher cognitive functions, then you did consciously experience it. But then there's this controversial case where you get the kind of activity that happens within the visual system itself when you uncontroversially do have a conscious experience. But because there's no connections forward into frontal areas, you're not necessarily able to report that information. And it seems like we might just forever disagree about whether or not this information is conscious, because we have no way of testing what degree of accessibility is required. So, I missed that. So I'm just going to, since we're running out of time, I'm just going to conclude. So conclusions. First of all, finding neural correlates of consciousness in humans won't necessarily tell us in general terms what consciousness is, because we can't necessarily extrapolate to other creatures. Secondly, reading the contents of consciousness from neural activity requires a bridging principle, like the accessibility thing, but that may be forever untestable. Finally, even if we got past these hurdles, there's still this thing called the hard problem of understanding why it is that the physical basis of consciousness gives rise to consciousness. Why is that the basis of consciousness at all? So that's it. Thanks.